Okay, the last one for this section is 8.4 Day 2 Linear Programming. And in your notes, we've given you all the steps that you need. And this would be a good list to refer back to when you're kind of stuck and you're trying to work your way through it. We identify the variables, we write constraints, we write the equation to be maximized or minimized. There's always something that we're trying to maximize or minimize. We graph the feasible region. Remember, the feasible region is where everything overlaps. We find the corner points, and then we answer the question. So we're going to start with, as always, I like to breeze through those and just show you by application how they work. I think is what works best. And I don't want you to get overwhelmed by it, okay? We've got two new blends of coffee. We have deluxe and savory. And what we're going to do is we're going to actually build a chart to help us do our constraints and our profits. Okay, so we have deluxe and savory. I'm going to say that X equals the number of pounds of deluxe, because it's asked, and I'm going to jump to the end, how many of each should be made. Okay, so that's, remember, whatever they're asking, whatever we don't know, that's our variable. And then Y is going to be my number of pounds of savory. Those are my two new coffees. Okay, so I'm going to have deluxe, which is my X variable, and savory, which is my Y variable, and then I'm going to have a total number altogether of all of the number of pounds of coffee that we're going to have. Then the next part is I have each pound of deluxe has 30% Colombian and 20% Arabian, and each pound of savory has 35% Colombian and 15% Arabian. So I know I'm going to have Colombian coffee as part of these mixes and Arabian coffee as part of these mixes. Just okay. And so we've identified the variables. Next thing is the constraints. I know for Colombian coffee, it's going to be, the Colombian coffee is 0.3 is 30% of deluxe. We write 30% as a decimal, so I know that 0.3 of my X is going to be Colombian coffee. And then I know that the savory is going to have 0.35X, or excuse me, 0.35 times however many pounds of that there is. And then on the Arabian coffee, I know 20% goes into my deluxe. My deluxe is, so however many pounds of deluxe I have, 20% is Arabian. However many pounds of deluxe I have, 30% is Colombian. How many pounds of savory I have is 35% Colombian and 15% Arabian. And it says that the profit, okay, so I also need a profit statement. On deluxe is $1.25 a pound. So this is going to be, I'm going to make 1.25 times every pound of deluxe. And then I know that the profit on savory is $1.40 per pound, so $1.4 for every pound of savory. And that's going to be my profit. How many should maximize profit? So I want these numbers, I'm trying to maximize my profit. If I have Colombian, then now my constraint on my Colombian is 455 pounds. So I know that if I add these two together, they have to be less than or equal to 455, because that's all the pounds of Colombian I have. And however much Arabian I use in each of these, I only have 250 pounds of Arabian. So whatever I use has to be less than or equal to 250 pounds of Arabian. Okay, so these are my how do I want to say, these are my constraints. Okay, that was part B. Part C is to write the equation to be maximized or minimized. I'm maximizing profits as a greater than. Now we're going to graph these. And I'm going to go by 200s, because I have 455 here. So I'm going to go 200, or by hundreds, I guess is. Wait a second. Let's actually go by 200 every one. So that's 200, this is 400, 600, 800, 1,000, 1,200, This would be 14, 1600. And then this last one, 18, 2000. Okay. And are my X values my deluxe? My deluxe is my X. And this is number of pounds of deluxe coffee. Okay. And as I'm looking at that, let's see, I'm going to need... We may go back, and this is great for you to watch this process. I may go back and revise this. I need to see what my X and Y intercepts are going to be before I decide for sure. So for the Colombian, I need to find my X and Y intercepts. If my X is 0, I'm going to plug in 0 for X. I'm going to take 455 divided by 0.35, and if I do that, I get 1300. So yeah, it's going to be a really big number. If I plug in 0 for Y, I'm going to take 455 divided by 0.3, and that's 1,516.7. It's 16.7. So I think I'm on the right track here, where I'm going to have, you know, on one axis I'm going to go up to 1,300, on the other I'm at 15. So I think going by 200 is good. So this is going to be 400. No, that's 3. This is going to be 400, 800, 12, 16, and 2000 as well. And so both of these axes are being done by 200s. Remember, if you're going to change the scale, that's fine. You just need to let me know what it is. And this side is going to be the Arabian. And that's the number of pounds of Arabian coffee. Okay, so first I'm going to graph my Colombian, and I'm over 15, 16. That's really hard to do. So this is 1400. It's going to be roughly right about there. You can just your best estimate. And then 0, 1300. That's 12. That's going to be halfway there. And these are all solid lines because I have equal to signs. So I'm going to take this and draw that. And then if I test 0, 0 to graph, 0 plus 0 is less than 455, so it's true. So that means I'm going to include this origin point for this graph. Okay. Now I'm going to do the Arabian. I'm going to do its X and Y points. If my X is 0 for Arabian, I'm going to take 250 divided by 0.15. And I'm going to get 1,666.7. And if I plug in 0 for Y, I take 250 divided by 0.2, and I get 1,250. So I have over 0 and up 16.667, which I'm going to say is right about here. And then over 1250, and up and down 0. So I'm going to connect these. And when I test my test point of 0, 0, 0 plus 0 is less than 250, so this is true. So this one's also being shaded below. But this one went to here. And then I have to look at my profit. And for my profit, I want to maximize that. So what we're going to do is we're going to find, before we can do our corner points, what we're going to do is look at what our feasible region is. And our feasible region for these two constraints is where they overlap. And they overlap right here. So anywhere in this area is going to be my feasible region. And so what I'm going to do is I'm going to find all the corner points. And the corner points are here, 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 and here. Okay, so I know one corner point is 0, 0. I'm going to put my corner points here. Is 0, 0. I know one of my corner points, if I go up here, this is 0, 1300. I know if I go to this one, this is over 1250. comma 0. And then I've got to figure out what this corner point is. So to find this corner point, I'm going to find what solves these two equations. Okay, as if they were equals. Because remember, if you have two lines that are set equal, that are a system, whatever that point is where they meet is your solution. So to find that point, I'm going to have to solve my two constraints. So 0.3x plus 0.35y is less than or equal to 455. And I have 0.2x plus 0.15y is less than or equal to 250. And I have to solve that system. And what I'm going to do is I'm going to try to eliminate my x's. So I'm going to multiply this by 2 and the bottom by -3 so that I can get those to cancel out. So I have the first one's going to be 6x plus 0.7y, 2 times 0.35, is less than or equal to 910. And then -3 times 0.2 is -6x. -3 times 0.15 is a -0.45. Y is less than or equal to -3 times that is -750. Okay, I'm going to solve this. I'm going to eliminate this. So I have 0.7, that's like 0.70, minus 0.45 is 0.25y. And that equals 910 minus 750 is 160. If I divide both sides by 0.25y, I get 640. And I'm going to plug it back into one of those original equations to find my x. I'm going to plug it back into the first one. So I have 0.3x. Oh, sorry guys. 0.3x plus 0.35 times 640 has to equal 455. So 0.3x, if you do all of that, multiply that and then subtract, you're going to end up with x is 770. So my fourth corner point, this one, is 770, comma 640. These are my corner points. All right. And then the last question is, we want to maximize our profits. So what you do is you have to look at your corner points to figure out where the most profit is going to be. And it's going to be this corner point that goes, your profit goes up and out. So this corner point here where those two meet is going to be your highest profit, where it pulls up and out at the same time. And so what I'm going to do is I'm going to plug in actually, we don't want to assume, I shouldn't assume what the point, what we need to do is the highest profit is going to be one of the corner points. It's probably not going to be 0, 0, because if you plug in 0 and 0, you're going to get 0, right? And we can plug it into any one of these, or actually into the profit. We want to know which of these points is going to make our profit the highest. If I plug in 0 and 0, I'm going to get 0. So that's not going to be a very high profit one. But if I plug in 0, comma 1300, and so I have 1.25 times 0 plus 1.4 times 1300, and I work that out, that one will give me $4,280. If I use 1250, comma 0, that's my next corner point. I'm going to take 1.25 times 1250 plus 1.4 times 0. And if I plug that in, the total is 1,562.50. And if I plug in this last corner point that we found, I have 770, comma 640. So I have 1.25 times 770 plus 1.4 times 640. And if I multiply that out and put it together, I get 1,858.50. So that this corner point here was not my best profit. My best profit is going to be this one here, is at 0, comma 1300. So I'm going to make the most profit if I don't buy any, if I don't have any deluxe and I make all savory. It's going to give me my most profit. Actually, I wrote that number down wrong. If you multiply this out, It's not 4,000, it's 1,820. So if you take that into consideration, it's a good thing these pens are erasable. If you take that into consideration, really the test point, the point that we found was the one that gives us the best profit, because it's 1858, that one's only 1820. And so you would get 770 pounds, you would make 770 pounds of deluxe and 640 pounds of savory to have the highest profit margin. Okay, so let's try it with another one. Okay, and again, we're going to be looking at our constraints and our variables. This time, I go right to the bottom to figure out what my variables are going to be. And in this one, we want to know how many each type of sandwich. Well, how many of each type of sandwich. So my X is going to be my, let's see, we've got traditional and double T. So X is going to be the number of traditional sandwiches. My Y is going to be the number of double T sandwiches. I don't even know what those are. See how you can figure out what you're doing without even understanding the problem yet. Okay. But I need to know how many of each of those I have. And so I'm going to end up having my little chart, right? And the traditional sandwiches, I have X of those. My double T's, I have Y of those. And then I have a total. And the traditionally uses 2 ounces of peanut butter and 3 ounces. They're all peanut butter and jelly sandwiches. So I've got to know how much peanut butter and how much jelly I need. And then, of course, there's going to be the profit sentence. Okay, so in a traditional sandwich, I have 2 ounces of peanut butter. So I'm going to have 2 ounces of peanut butter for every traditional sandwich. And the double T uses 4 ounces. So I'd have 4 ounces of double T for every, 4 ounces of peanut butter for every double T. And on the jelly, I need 3 ounces for my traditional sandwich, and I need, how much do I need in here? 5 ounces, wow, that one's loaded up, in my double T. What I do know is I have 250 ounces of peanut butter. So all of this peanut butter that I use has to be less than or equal to 250. And I have 345 ounces of jelly, so all of jelly I use has to be less than or equal to 345. And then my profit is, the traditional sandwich is $2 profit per sandwich. The double T is $3.50 profit per sandwich. And of course I want that to be maximized. So we're gonna graph each of these. I'm gonna start with the first constraint is on peanut butter. So I'm gonna do an X and Y table on peanut butter. If my X is 0, I'm gonna take 250 divided by 4. That's 62.5 for my Y. If I plug in 0 for Y, I'm gonna get 125 for my X. So I'm gonna have to change my scale again. I think on this one I'm gonna go every 15. I'm gonna go, so this is 30, 60, so this is gonna be by 15s. 90, 120, this is also 30, 60, 90, 120. And so it's over 0 and up and down, it's 0, it's 0 left, right, up and down 62, and 125, comma 0. These are, again, solid lines. Yeah. I don't like the way that came out. Okay, be careful when you graph these that you make them as accurate as possible, because it could affect your profits. So I'm going to make sure. And I know that we kind of estimated where those points were, that was way off. Okay. And then I'm going to do my test point. Whoops. My test point is 0, 0. If I plug that into this first equation, 0 plus 0 is definitely less than or equal to 250. So I'm going to shade to include this point. All right. Then I'm going to shade the other point. Or the other point. I'm going to shade the other. Well, I'm not shading. I'm tired though. We're going to graph the jelly. And so I'm going to do the X and Y for the jelly. And if my X is 0 on my jelly, I'm going to take 345 divided by 5 and I get 69. And if I plug in 0 for Y, and I take 345 divided by 3, I get 115. And if I test 0, 0, so So let's do this first. 0, 69, it's a little bit above this one. And 115. So these are really close. And if I test 0, 0 on this one, 0 plus 0 is still less than 345. So that's true. So I'm also going below on this one. So my solution area is where they overlap. And what we need to do is find our corner points. So for my corner points, I always have, it's easy on the long lines. I have 0, 0. And then this is 0, 62.5. Right, because it's the lower one of the 62 and the 69. Then this one over here is going to be this smaller one, which is the 115, 0. And then I've got where they meet. And I've got to figure out which one that is. So what I'm going to do is I'm going to try to solve this system of these two equations. And I can eliminate, if I multiply the top one by 3 and the bottom one by -2, I can eliminate my x's. So I'm going to have, if I eliminate multiply the top one by 3, I have 6x plus 12y is less than or equal to 750. If I multiply the bottom by -2, I have -6x minus 10y is less than or equal to 690. 12y minus 10y is 2y. If I add 750 and 6, actually this would be a -690, right? Because I'm multiplying by a negative. If I subtract those, I get 60. So y equals 30. If I plug that back into this original one, I have 2x plus 4 times 30 is 120 is 250. And if you work that out, and I know you guys knew how to do the algebra, this is 65. So this corner point is 65, 30. And so now what we've got to do is to figure out what the highest profit margin is. We have to do all of our corner points. If I plug in 0, 0 into our profit statement, if I plug in 0, 0, I'm going to get 0. So I don't even mess with that one. That's clearly not going to be a profit. So the next one I'm going to do is 0, 62.5. If I plug that into my profit, I have 2 times 0 plus 3.5 times 62.5. And if I multiply that out, I get $218.75. If I plug in 115 and 0, I get 2 times 115 plus 3.5 times 0. And if I do that, I get $230. That looks better. Okay, and then I also have to do this point out here. So I've got 65, 30. And that's going to be 2 times 65 plus 3.5 times 30, which is going to give me $235 profit, which is my largest. So that means that I'm going to buy 65, or I'm going to make 65 traditional sandwiches and 30 of the double T's. And what's interesting about that is, if you want to think about this, you tend to want to think that I'm going to do more of the double T's because I make more profit, but you're constrained by how much jelly you have, and so you have what's the best combination of profit I can get with the limitation of the peanut butter and jelly, and that's a very real world kind of thing. You can't just if it was just straight profit when we had an unlimited supply, then we would just make all double T's, but that's not always the case. And so you really do have to work through the constraints to figure out what the best solution is going to be.